This is Geometry Lesson 5-1. Today is January 17th. Today we have a digital day because a lot of students are not going to school today because of the snow. Alright, so this is our new unit, Unit 5. We just took our test on Unit 4 yesterday, so there are a few new things. There's a unit guide that's already been posted to Google Classroom, so make sure that you go and bookmark that. We're going to be updating it every single day. Other announcements, we're going to have a new seating chart when we get back to school, and aside from that, let's go ahead and start on the notes. So this is what I expect. If you have a printer, then print out these notes. I posted them on Google Classroom, and then you can take the notes with me. Regardless of what happens, you are going to be doing these notes. You're either doing them now with me or later on your own time. So, vocabulary, right triangle. And oh yeah, so if you don't have a printer and you want to not take the notes, then just watch this video. You can watch it at ×2 speed or whatever you want to do. Watch the video and then do the assignment on Khan Academy. The assignment on Khan Academy for everyone, regardless of if they were taking notes, is going to be due tomorrow on Friday. All right, so right triangle. What do I mean by right triangle? It's a triangle that has a 90-degree angle. So this down here is an example of a right triangle. It has a 90-degree angle. It's notated like that. I think we've seen it before. What do I mean when I say a leg? When I'm talking about a right triangle, and we're only talking about right triangles for this whole unit, when I'm talking about a right triangle, the leg is these non-hypotenuse parts. So it's these, I guess it's the lengths, GTH, lengths touching the 90-degree angle. And if I was being more formal, I would say it's the lengths adjacent to the 90-degree angle, but it's these two lengths here. So this is the 90-degree angle, this leg is touching, therefore those are the legs. And then the hypotenuse, it's the longest side. And the way that we say that is it's opposite, it's across. I'm going to say across. We're not being too formal now. We can be more formal once we get into trigonometry, but it's across from 90-degree angle. So across from the 90-degree angle is over there. That's the hypotenuse. It's the one that looks diagonally. It's the C right there. All right, so Pythagorean Theorem. Practice saying Pythagorean because we're going to be saying it a lot this unit. Pythagorean Theorem, it is a squared plus b squared is equal to c squared. I'm just giving it to you for right now. Tomorrow and on Friday, we're going to be doing some fun proofs, maybe doing President Garfield's proof. There are so many proofs of Pythagorean theorem. All of them are pretty fun. But for now, here's a formula. So let's use our formula. Example 1, find the value of x in the triangle below. Oh, sorry, I skipped over this, but a and b, they match with this triangle on the right. So a and b are the legs. It doesn't matter the order in which you put them, but c has to be the hypotenuse. So the hypotenuse is on one side, the legs are on the other side, and you have to square them individually. All right, so example 1, find the value of x in the triangle below. All right, well, I know that Pythagorean theorem says I'm going to do this thing squared plus this thing squared is going to equal this thing squared. Let's write that out. That means 5 squared, got something like 5 squared plus 7 squared is equal to x squared. Just setting it up so the hypotenuse is on the right-hand side, the legs are on the left-hand side. Seems good so far. Okay, 5 squared is 25 plus 7 squared is 49, and that's equal to x squared. You can't do anything with x squared yet. Now I'm going to add 25 plus 49 to simplify the left-hand side, this expression. So 5 plus 9, that is 14. Carry the 1 from the 14, the tens place. So 1 plus 2 is 3, plus 4 is 7, 74. And that's equal to x squared. All right, now I need to solve for x. So many people think you can just divide both sides by x. Well, you can't do that ever in mathematics because what if x was 0? I mean, physically it can't be 0 when it's a triangle, but you can never divide by x. The only way to solve for x is to square root both sides. So here I'm going to square root the left and square root the right, keeping both sides equal. The square root and square will cancel each other out. So this square root and that square are gone, and you leave the x. And x is equal to the square root of 74. We will eventually learn or review how to simplify radicals. For now, just leave it as square root of 74. Final answer, box it. Okay, so now we're going to go kind of backwards where we are given the hypotenuse and we need to find one of the legs. So again, you're just using Pythagorean theorem. Here it is again, it's a squared plus b squared equals c squared. The legs, you add them up when they're squared and you set equal to the hypotenuse squared. So 6 squared plus x squared equals 10 squared. And I could have written x squared plus 6 squared equals 10 squared. It doesn't matter the order of the legs. I'm just randomly deciding it's going to be 6 squared first plus x squared is equal to 10 squared. So I set up my formula using Pythagorean theorem. Now I need to solve for x. All right, well, I know what 6 squared is. 6 squared is 36 plus x squared. I can't do anything with that yet. That's going to be equal to 10 squared, which is 100. 100, like that. All right, let's go ahead and solve for x squared. So I need to get this 36 on the other side by subtracting 36 on both sides, minus 36, minus 36. That will cancel out my 36, and I'm just left with 100 minus 36, that is 64. All right, so 64 is going to be set equal to whatever's left on the left-hand side, which is x squared. All right, so from now I need to get rid of this squared, and you know how to do that from our last problem. To get rid of the x squared, the squared and the x squared, I should say, you need to square root both sides. Square root, and you're left with x is equal to square root of 64. This is the case where you need to be able to simplify. If it is a perfect square, you should be able to simplify it. And again, perfect squares, I can write them really quickly on the side if you don't know them. 1 squared is 1, 2 squared is 4, then 9, 16, 25, 25 is 5 squared, 6 squared is 36, 36, 7 squared is 49, come on now computer, 49, 8 squared is 64, 9 squared is 81, 10 squared is 100, and I think you only need to know 1 through 10 for today's homework. So I'm going to assume that that's all you need. If you see any of these numbers, know that they have to be simplified. So square root of 64 in this case, square root of 64 is 8. So x is equal to 8. And that's our final answer, so box it. All right, so that's the first half of the homework. There are 2 homework assignments. Homework assignment number 2 is going to look like this, where we have isosceles triangles. All right, so how do we do these? We're going to have to find the value of x in the isosceles triangle. So this one looks a little bit hard, but because it's isosceles, that means that this length and this length are the same. Well, if this whole length was 6, that means this small length here was 3, because I divide 6 by 2. So divide this whole length by 2 to get one of these side lengths. Eventually we're going to be doing that again and again, so know that you can always split this into halves. Alright, so once I have my right triangle, I'm going to basically disregard this left-hand side and only deal with this right-hand side. I know that I have a 3 and a 3 and an x, so use Pythagorean theorem again. Pythagorean theorem says leg squared plus leg squared equals hypotenuse squared. 3 squared plus 3 squared is equal to hypotenuse, which is x, squared. All right, so go ahead and simplify. 3 squared is 9 plus 3 squared is 9. That's equal to x squared. Well, I know what 9 plus 9 is. 9 plus 9 is 18 is equal to x squared. And finally, I need to get rid of this square. The way that we get rid of that is a square root, and I'm left with just an x because the square root and square cancel each other out, and x is equal to square root of 18. And that's all there is to it. Box it. Box our final answer. Let's try another one, example 4. So find the value of x in this isosceles triangle. All right, so I'm just going to first start by finding this length right here. I'm not going to find x all at once. I'm just going to find half of x, and then at the very end, I'll double it to get all of x. So remember that my very last step is going to be to double it because I'm only finding this missing angle here. I'm going to say that this missing angle, or this missing length here is y. All right, so let's set up my Pythagorean theorem. I know that a leg squared plus a leg squared is equal to the hypotenuse squared. So here I have a leg squared, y squared, plus 10 squared is equal to 100 square root of 149 squared. So I have 149, that's being square rooted, but I'm also going to square it. All right, we know from experience up here that if I have a square root and a square, it can be on both, or sorry, the square can be on the inside or the outside. In this case, the square is on the outside, but they cancel each other out. So this square root and this square cancel each other out, and you're left with just 149 with no square root. And I can do 10 squared. 10 squared is just 100, and I still have y squared being added to this. And then from there, we need to get y by itself. So I'm going to move this 100 to the right-hand side by subtracting 100, minus 100, minus 100. And that gets rid of the 100. And I'm just left with a y squared. That's going to be equal to 149 minus 100 is 49. 49. And then from there, I need to get rid of the square. And we saw the way that we can get rid of a square, or to cancel it out, is by doing a square root. So in this case, I'm going to square root and square root both sides. That will mean that the square root and square cancel each other out, and I'm just left with a y is equal to square root of 49. But the square root of 49 is in the list of squares that you should know. Square root of 49 is 7. So y is equal to 7. That's our final answer, and box it. Ooh, sorry, that's not our final answer. Y is equal to 7, but we needed to find x. If y is 7, that means half of this length was 7. The full length I needed to multiply by 2. We forgot to do that. I forgot to do that. So now I'm going to multiply by 2, and then that will give me x. X is equal to 14. That's our final answer, and box that one. Oops, let's get rid of that. All right. On to our final example, example 5. So example 5, again, we're going to disregard the left-hand side of the triangle. The right-hand side is the one that we're going to be working on. This is a right angle. This whole length was 12. That means that this length over here is just 6. So again, use Pythagorean Theorem. So x squared, the leg squared, plus the other leg squared, 6 squared, is going to be equal to the hypotenuse, which is the square root, square root of 61, and then all of that quantity squared. Okay, just like before, the square root and square cancel each other out. I'm just left with not 16, I got some dyslexia going on, 61, and that is equal to 6 squared, which is 36, and x squared being added to that. All right, so next step is to get rid of 36. I'm trying to solve for x, so subtract 36 on both sides, minus 36, minus 36. And that'll eliminate the 36, leaving behind an x squared, and then on the right-hand side, 61 minus 36 is, what is that? So 60 minus 36 would be 24, so it's 25. And then x squared is equal to 25. I'm going to square root both sides in order to get the square to cancel out. So square root and square root. The square and the square root cancel each other out, and I'm left with x is equal to 5. All right, that concludes this video. So go ahead and write your summary now if you are taking notes. Again, these notes are going to be due on the next binder check. You are responsible for doing that on your own time. So for the homework, again, because a lot of you are not going to be at school, there is paper homework, and I uploaded it to Google Classroom. If you want to print it out and do it, you can do it that way. Paper homework you can just do on a separate piece of paper to show your work, and that will count. And of course, if you want to do it on Khan Academy, it will be posted on Khan Academy. All of that is going to be, all the homework is going to be due tomorrow, and those notes are going to be due on the next binder check. But I definitely suggest getting that done in the near future. All right, thanks. I'll see you guys tomorrow.